Hi guys, my name is Musa Tigeniu. I'm making my presentation on web analytics, data 620. This is my project 2 presentation. The instruction given is as follows. We have to identify and load a data network data set that has some kind of a categorical information for each node, and that's why we have to for each node we have to calculate the centrality and the eigenvector centrality, the degree centrality, and we have to compare the centrality measure across all the categorical group. Uh, for you to access the dataset, you may want to follow this link. Before we continue, let me put this straight. I'm working on Jupyter using R programming. We have to load all this library for us to be able to use it. Here is loading on my dataset. The dataset comprises of 5960 observation with 3 variables. Columns, right? So I decided to change the name to ID from to I believe we have the PST, and then we have the origination and the destination as a column names there. So I changed it to these, and I decided to reduce the number of rows to like a 1000 observation. Here is a glimpse of it. So we have the ID, we have uh, the origination, and then the destination. So the data type is an integer data type, uh, and again we like to make a kind of a graphical representation of the data. So I decide for simplicity to reduce the number of the sample size to 100 by replacing it. So we're gonna see the difference between the 1000 data set and then the UNM data set. So by doing that, and I converted it to the iGraph table. So here is the number of nodes. We have 1,268 nodes and 1,000 edges. Um, and here is a plot for the 1,000 observation. We use the layout as a KK. In iGraph has a lot of layouts you could mix it up. So I decided to use a layout with KK. And here is a plot of 100 observation. And here is, you say the beauty of iGraph is that, as I mentioned, you could change the layout as you want and then see for yourself. So it will be much more explanatory for a layman. So, if you want to explain to a layman, you showing them the graph does it how. So um, here is it. So that is the link there, and here is the edges. So we want to get the extract out the edges. Here's how the edges look like. This links to that, that links to that, this or to that, and then to the for the vertex. Here is it, and then here is the mean of the edge, and then we obtain the mean of the vertices as well. And again, we obtain the standard deviation so as to quantify the amount of deviation or dispersion of set for both node and edge. This is used just to know if there is a deviation from the mean. So we want to know how close uh, is the mean to the two data. Yeah, we see that this one is lower, so it's not as what we expected. The more standard deviation it is, the more deviated it is, and the more low the standard deviation is, the more close together they are. So here we obtain the edge list. We want to go with the edge list, we get something like this for the edge list. And then for the histogram as well, we obtain these as the histogram, the frequency, and yeah. And to the degree centrality. Degree centrality is used to obtain the number of link uh, incident upon the node. So we want to know the number of ties to a node. So from here, we use that is mathematical representation of the degree centrality. So where the h is the maximum value, graph is connected to one node to which the other nodes are connected. So here it is. And if you want to see, here is like this. Um, okay, here's how this like. So I took out the summary here, and you see we have a 0, 0, 0, 1, 1, 1, 1, 12. So where 12 is the maximum here, as we saw here earlier. So for the degree centrally, and then for the closeness as well. So closeness is used to obtain the average length of the shortest path between the nodes and all other nodes on the graph. So, and then from there we move to vector centrality. Vector centrality is used just to measure the influence of a node in a network. That is, we want to know, as we believe that a node with higher scoring, will have more power compared to a node with low scoring connection. So here is a again centrality, and here we can see from here as well. It's a little bit, so it takes a lot of space, so that's why I try to get the summary over there. So yeah, that's for the closeness, and then you see, and here is for the again vector centrality. Get that so long. For a better output, we normalize it. And yeah, from there you say so long. From there we move to the between x. So between x is a measure of the vectors. So within the graph, that is, if you want to measure the number of geo, this is that passes through the nodes or the edge. So this is how it is expressed mathematically. Where these sigma st is the number of shortest path from the node S to node T, and then sigma st of V is the number of those paths that pass through V, and here is the mean of it. So we get the average because it's taking on a lot of our spaces. Yeah, and we obtain the distance as well. So the mean distance, we get that. So from here we are trying to get these as well to get the top flight number of departure, so of the top airline. So here is what we obtain, and then we try to get a scatter plot of it. As we can see, the plot is going from up down here, and then the line here, so most of it they are close to these, but from these it shows this is a kind of a graph that goes kind of a negative kind of a graph correlation. So as I saw that, I try to obtain the correlation test at 0.95 degree coordinate level. So I apply all those methods. I use a Pearson, the Kenda, and the Spemaran, and I obtained the correlation of 0.48. So here this shows that there is a correlation, as though there's a correlation, but the correlation is a negative correlation between the the departure and the destination from the from and then the to. And I went ahead to do regression analysis. Regression analysis is used to know the degree of the relationship in between them. So this is my test of hypothesis. I have a null hypothesis to be their means are equal, and then the alternative means their means are not equal. So I have a decision to reject H naught, which is the null hypothesis, if the p-value that I'm gonna get is greater than, is less than the table value. Otherwise, I will not reject it. So here is a simple linear regression that I did, and I obtained the p-value here to be this, which I believe is much more lesser than the 0.05, which is the table value. So from here, I have to reject. So, but before I do that, I went further to actually obtain the analysis of variance of both, and then here is what I got. So it's almost like close to it. And then the confidence intervals will prove it right, because we have a negative from here to here, so that is non-zero. So the value we're looking for, the experiment we're looking for, is going to be between this value. And then this one is zero, and this one is positive and this one is negative. Then we might say our data analysis is wrong, but we have to be negative and then negative, or we could have it with positive and positive. So that shows the what we have here is really is correct. So we therefore, since our p-value is less than the table value, we therefore reject h naught and accept h1. So we conclude that they have no equal means, and our the expected value here, here, which is a non-zero rather, buttress our point. Thank you.